Okay, hey, welcome back. So we're going to be covering chapters 8 through 10 in the big book. So let's get cranking. Chapter 8. So chapter 8 is on user management. And so we've done this before. We've created users and deleted users. That's what we're talking about. But you can kind of sort of see how if you had a whole bunch of machines, that you probably need some sort of a centralized management of that. I mean, if you had 100 Linux machines and you wanted to add a new user that could go to any one of those machines, that means you walking around to 100 machines and logging in and using the SU command to build the thing. That's not the way to go. So obviously there's an awful lot of other choices. We talked about this before, that Linux is kind of sort of designed like a plug and play kind of a thing. You could have other types of systems plugged in. We talked about in the file system, for example, you could have the Microsoft file system, so it had permissions. Well, the same thing with the accounts. You could have an LDAP, that's a cool acronym, Lightweight Directory Access Protocol, an LDAP system like Microsoft uses in Active Directory to manage all the accounts and then have that put down on here. Now, the weird part about this is the system has got some really cool tricks. Even if you have LDAP turned on and you're no longer doing walking around 100 machine kind of a thing, you can still use like the add user command. It's just the add user command is smart enough to look and say, what environment am I in? Am I in the normal traditional everything stored in files environment, or am I in some other kind of environment? So it's kind of cool that you can just kind of close your eyes and just do the thing you've always done, and it automatically does the right thing. Pretty damn cool. Okay, so in the book they talk about account hygiene. That's a cool term. Things that you might have to do as an administrator, like finding out accounts that haven't been used in a really, really long time. Maybe search for people who have very short passwords. Or maybe you need to remove an account. Or maybe you need to lock an account. For example, if somebody's getting ready to go on vacation for 2 weeks and they're not authorized, remote connection, go ahead and lock their account for 2 weeks and remember, of course, to unlock it when they come back. But that way, no one else, you don't have to worry about any security issues because you've locked the account. Okay, on page 244 they talk about the mechanics. So in the beginning, everything is stored as text files. You've seen these. You've seen the etc password and the group. I've shown you the shadow guy as well. These are all just text files that contain account information in them. So that's, we're not going to install LDAP. But my point is, this is the normal kind of way that Linux works in a standalone environment. It's all stored in text files. And then I'm going to go to, as soon as I get focused, I'm going to go to etc. And we're going to look at something called the NS switch. So I'm going to do a NS switch. Why don't I just do an asterisk since I can't type it? Config. So what this basically says is, this is the way you tell the machine what system I'm using. Oh yeah, I'm just using plain old files, okay? So systemd and group and shadow are all using the standard compatible systemd kind of things. And group shadow is just a file, and host is done with files and DNS and So this is just a way you can tell the machine, oh, by the way, I've installed LDAP, and then from now on, when you run the password command, it will know what to do. Cool. So the way of thinking about this is a level of abstraction. You've put something in here so that you don't really need to pay attention to what's going on behind the scenes. In other words, let's say you had the traditional and then you decided to install LDAP instead. You probably wouldn't have to tell your users anything at all, because when it came time for them to change their password, they would still run the password command and it would still work. Okay? So that level of abstraction is good because you don't have to retrain anybody, not you, the administrator, or your users. Kind of cool. Okay, now we've talked about the password file. It's one of our favorite files that we use for copying for whatever reason. So I'm going to do a lesson on etc. Password. Dang it. Helps if you spell it right. Okay. Okay. Now we've seen this before. This is one of those colon separated files. So let's just go through it one more time. So the first one is the login name. So example, let's go to the bottom. Well, there I am. Okay, Emmett Gray, boom. The second one used to be the hashed password. It's not anymore. It's just an X. The next one is the user ID, my primary user ID, which in my case is 1,000. And my primary group ID, which is 1,000. And then this next field actually has a title. Believe it or not, it was originally, there's a little bit of history behind it. It's kind of cool. In Bell Labs, when they were developing the UNIX system originally, they had some printers that they needed to use. And so they were GE printers. And so there was this little office automation system called GECOS. And I think it had something to do with, General Electric, something, operating system. And so it's called the GECOS file, or field rather. Obviously, we didn't. And so they would put in there what printer that you were assigned to. Obviously, we don't use it for now. Now we use it for what is your full name and maybe all sorts of other stuff. So you can see the Bob Smith went down at the bottom and the Emmett Gray went up a little bit further. That basically tells me now, it just tells me who I am. The home directory, and then what shell I'm going to use. Okay, so let's talk about the login name. So to be POSIX compatible, it has a 32 character maximum, okay? And the POSIX standard basically says letters, numbers, dots, and dashes, and underscores. However, Ubuntu tightens it. Basically, it says it has to start with a lowercase letter, and you can't have a dot. That would just kind of confuse things. So they've tightened up more than what the original POSIX standard allows. So it starts with a lowercase letter and with no dot. They are case sensitive, unlike Windows. And of course, if you have multiple PCs, you would have to use the exact same name in all the machines, which is why, of course, going around 100 machines would be a dumb idea. The next field, of course, going through this list a second time, the hashed password. Okay, so obviously this file has to have read permission to everyone for a lot of things to work. That's just the way it was designed. So I don't want you to see my hashed password. So they changed it. They moved it out to something called shadow, which does not have read permission to everyone. It also originally used the DES encryption standard. If you haven't taken a security course, just kind of nod your head and go, okay, whatever. So DES is kind of an old one. Right now it's SHA-512. That's very, very good, strong encryption. And after I'm going to go ahead and show you that guy. So I'm going to have to do a sudo because, right? So less on, etc. shadow. Okay. So that long gobbledygook stuff at the bottom, that is an 86 character encoded version of my thing. It's called base 64 encoding. Not that really matters, but it takes a 512-bit thing and then scrunches it up a little bit so it makes it human readable. Okay. Now, one of the things that's kind of cool is, let's say I want to allow those dots back in. Where is the password policies actually stored? Well, believe it or not, we have a configuration file. So in Debian and Ubuntu, there's a thing called etc. D common password, and this is where how many characters and what kind of complexity to include the dot. You very well could go in there and change that and say, no, I want to allow the dot character. 6 characters, quite frankly, is a little low. Most people today think that 12 characters ought to be the minimum. That's just a philosophical statement that, in other words, for something that's important, 12 characters is probably what you ought to have for a password. Okay. So getting back to the example with the file, actually not that one, the other one. Okay, so the next one, of course, is the UID. This is a 32-bit number, which means there's about 2 billion positive numbers. Okay, there's 2 billion negative numbers, but that really wouldn't be appropriate here. So about 2 billion. Now, I don't know about you, but the kind of places that I've been working don't have 2 billion employees. So I think we're okay. We're not going to run across any duplicates. A UID of 0 is extraordinarily important. That's different. That's the root account, and a root account is always 0. Let me tell you, I've seen some recommendations of people saying, you ought to rename the root account. You know, change it to something else. Call it, you know, kumquat or something. Don't leave it at root. And I'm thinking, that's dumb. It's not the name that means anything at all. It's the number, and you can't change the number for root. So don't pay no attention to those kind of recommendations. In our world, the user accounts, they skip over a bunch of them. So if you install a piece of software, it could go in and add probably whatever the next one is on the list. Up to 1,000, and then from 1,000, that basically says those are ones that you personally have added. So it doesn't really matter. You can skip around, and you can skip a bunch of numbers. It's okay. So in my case, I had me at 1,000 and Bob at 1,001. So they are sequential, which means if I'm adding an account to one machine, and then I go, oh, I made a mistake. Let's remove that account. And then I try to add it a second time, it's probably not going to reuse the same number over again. Because the UID, using this simple technique, has to be the same. That number has to be the same on all machines. Which means I can't have like 50 accounts on one computer and 75 accounts on the other. If you do, the numbers will never line up, will they? I mean, right? The likelihood of the numbers lining up is very, very small. So if you're going to have 75 accounts, you're going to have 75 accounts on every single machine. Unless, of course, you take one of the other approaches. Okay, cool. So group ID, this is what's called the primary group ID. And so the primary group ID is just the one that was assigned to you when they built the account. It doesn't really have any real special meaning other than it's the one that's in the password file. Seriously, it doesn't really matter. Really, really, really. I remember there's a group file which shows all the rest of your group memberships, etc. groups. And it uses the same thing, the same numbering system, you know, just like the UID, you know, and the GID, you know, if they start at 1,000 or 100 and, you know, they're sequential and they have to be the same on every machine. That same old we just talked about. So for security reasons, there's nothing really special about that security one versus the secondary ones. So if I go over here and look at less, etc. group, okay, so I see a couple of Emmett Grays in there, and when you get down to the bottom, you should be able to see me. And so I started at 1,000, just like we did on the password file, and my name appears in a bunch of these guys. Cool. Okay. So there's no, from a security point of view, there's no real difference between a primary group and a secondary group. Okay. Back to the other guy we just talked about. Whoop. Okay, the Geicos field, which obviously we only use it for putting in users' names. And, you know, in my day, we put in like what building they were in, because, you know, I was in the organization that had like building names or building numbers. So that way you could put their phone number in there, their primary points of contact, something like that. So if I wanted to say, hey, you need to get off the system, I could call them up on the phone and say, hey, we're getting ready to shut the system down, you know, that kind of thing. So it's a free-for-all. You could put practically anything you want in that particular field. Okay, we're coming up on the 15-minute mark. You know what's going to happen.